There's a number of different locations where arc flash, fault current, coordination studies, all these things show up within code. And then even in the chapters 1 and 2, we have requirements in 110, we have requirements in 240. So this isn't necessarily something that's new. I would say it's something that hasn't been maybe applied within the PV industry, maybe even as much as it should be, but we're definitely starting to see that change. And so working with partners like ETAP, learning these systems has been a big part for us in terms of some of the services we're offering, and helping the clients make sure that they are code compliant and they are making sure that these systems are as safe as they possibly can be.
Load flow analysis or a load flow study. And what it does is it simulates the power flow of an electrical system during when you're doing the design stage. And this is so important because it helps us size equipment such as transformers, cables, inverters, and very importantly, conductors. So when you're doing a short circuit study, the software will automatically compare the calculated fault versus the interrupting rating of the equipment. So potentially making sure that the equipment is properly sized, right? And in the event of a fault, the equipment will function according to the manufacturer's specifications. In this case, you notice that there are multiple protected devices that trip. These are the red squares. Those are protected devices that opened. So if the system is not properly coordinated, it could bring down your whole system, right? A fault on the low voltage side can go all the way out to your main and essentially bring down the whole site, the whole operation. There is a comprehensive library for everything from batteries to PV. The software allows you to connect the PV cells you select in parallel or series, smart inverters, protected devices, down to cables, right? Different manufacturers, and you just basically, like AutoCAD, you plug and play, connect them, and then just run your desired analysis. As you begin to get into other renewable type projects like microgrid design and analysis, you could now take the same platform and do design of microgrids as well as perform the power system studies that we mentioned earlier.
This particular project was a PV only installation. Our client came to us with 10 sites that they were developing and needed plan set, design review, EE stamps, and power system studies. The goal of hiring on Mayfield was to help provide NEC compliance, protection coordination, and arc flash labeling. By using ETAP, we were able to model these circuits by taking into account this layout, the soil temperature at the desired conductor depths, soil thermal resistivity that we got from a geotech report. And we also included SAM modeling. The SAM modeling allowed us to produce a transient load profile so that we can account for the daily cycling of the PV asset. We take all of this and we integrate it into our ETAP model, and then we can run the short circuit study, which will either verify or cause the need to change certain equipment through the system. And like I mentioned before, we like to do this at a certain point in the design so that we can capture issues before equipment procurement. ETAP software allows us to create these time current curves on the left-hand side here that allow us to properly coordinate the different overcurrent protection devices in the system. And then we're able, and once we've got that all built and coordinated, we can then verify it, like Victor showed earlier, by inserting a fault in a particular location. Once we have this model built, then we can run the arc flash analysis, and that produces all the information that would go on the arc flash labels, such as the incident energy, working distance, arc flash boundary, and required PPE for that hazard.